States of matter. This is something that most people has heard about. Most people actually know about. They've heard of the three basic types of states of matter, but what is actually happening to them? And here we go. We actually have our solids, liquids, and gases on the third slide. So most people has heard of solid, liquid, and gas, but what makes something solid, what makes something liquid, and what makes something a gas? I think the best way to think about this slide is actually just all matter is made up of atoms. Some atoms are formed into molecules when they are bonded chemically to other atoms, but matter itself is better thought of just be made up of atoms. Matter is made up of tiny, tiny little particles, the tiniest particles that you can even fathom. Now, once you get down to the tiniest particles, those are called atoms. Now, the best way of actually describing a certain type of matter would be to describe the atoms that make it up and the configuration of the atoms that are connected together. Now this is a cool picture, albeit a little bit confusing, but we have matter right in the middle, and matter is what we are talking about. That is the only thing that matters inside of this PowerPoint. Now, if you look at the top, you'll see the three states of matter. Then we have a picture of atoms at the top left, elements at the bottom left. Now, elements are made up of one type of atom. Molecules at the top right are made up of different types of atoms, and compounds are basically the same thing as molecules. Now, it may not surprise you, but being that atoms are the smallest part to matter, they all have the same properties of matter. They all have a volume, they all have a mass, and they actually all have a shape to them as well. And we are back to the states of matter. We have solid, liquids, and gases, and we're going to talk about how are they the same, how are they different, and what they actually mean. Now, please bear with me through this section because it may seem a little bit redundant, but most things at room temperature, which is the temperature that your house is normally at, exist in one of three physical states. Either they are solid, or they're liquid, or they are gas. And those are the three that we're going to be talking about today. But there are more. What is the difference between solid, liquids, and gases? Well, the first thing that we have to realize is that there are some things that all three of these things share in common. All substances are made up of particles. Now, this is the molecules or atoms that we were talking about earlier. Those are what the particles are. So anytime I reference particles, I'm actually talking about atoms or molecules. Now, the particles are attracted to each other. This is in every state of matter. And the particles move around. Even in a solid, they do actually move around. They are described as having kinetic energy. Now, as we increase the temperature of these objects, the kinetic energy increases. So if I'm saying the kinetic energy increases, I mean that the particles are moving around just a little bit more. First, we're going to talk about solids. Now, I did say that solids, liquids, and gases, all the particles are moving. In solids, as you may have guessed, they are not moving past each other. So this picture, this animation is showing what they are not doing. What they actually do is they vibrate in place. So they are moving around, but very, very close together. I would definitely write these things down because these will be on a test. The two things to write down is solids have a definite shape, and if kept at the same temperature, solids have a definite volume, which means they take up the exact same amount of space. Here in the example, we have a marble. The shape of a marble is a sphere, and the volume can be found either mathematically or we can drop it into a graduated cylinder and see how much the water rises. Let's talk about liquids. Liquids have particles that are actually still really tightly packed together, just like solids. However, the difference is that liquids have particles that are moving past each other, sliding over each other. unlike solids which were rigidly locked into place. Now again, the two things to write down about this is that liquids do not have a definite shape. They take the shape of whatever container they're in, but they do have a definite volume. If we put it in a graduated cylinder, we should be able to measure the volume of any liquid we have. However, the shape, on the other hand, takes the shape of whatever it's in. If I put it in a cup that looks like a cat, now the liquid is in the shape of a cat. Now we're talking about gases. Gases are really cool states of matter where the molecules are not only slipping past each other, they're bouncing off of everything. They have so much energy that they are just going all over the room without any restraint. The two things to write down about this state of matter is that they do not have a definite shape and they do not have a definite volume. It really depends where they're at for any of these things. If you are in a room that has a certain amount of gas in it, and then you open that room, that gas will escape into the other room and fill that room as well. Many people are familiar with water being able to be in any of these three states of matter. They've seen solid ice, they've seen liquid water, and they've seen clouds in the sky. How does any type of matter get from one state to the other? And the answer to that is energy, the adding or removing of heat. Now, this is an absolutely fantastic diagram. Now, in all these examples of the solid, liquid, and gas, I want you to think about these particles having attraction to each other, but they actually want to get away. Now, in the solid, they are all attracted to each other, but they don't have enough energy. They don't have enough force to actually separate from each other. But if you give them that energy, if you give them some of that heat, then it becomes a liquid. They're able to get a little farther apart, and now they're able to slide around each other, moving about freely, but they are still not able to break free. So you give them even more energy, a little bit more heat, and then finally they're able to break free from each other and start bouncing off the room, escaping into the sky. Wherever they want to go, they can go. But when you start to remove some of that energy from them, remember they have this attraction. So they clump back together and now they're back to a liquid. And even if you remove more energy from that, remove more heat from that, then they can't move around anymore. Wherever they were, now they are locked into place again as a solid. Now, this might be something that is a little bit hard to conceptualize, but there are two types of changes that go on. There is physical change and there is chemical change. Physical change is what we have been talking about already, with the three states of matter. They seem different, but their properties are the same. Ice, even though that it's solid water, still have the same properties as water. And water, even though that it's gas, still has the same properties as the solid state of it. It is all water. Now, chemical changes are different. Chemical changes happens when the actual properties change from one thing to another. This only happens when the particles either get separated, for instance, if I have water, H2O, and the hydrogen gets separated from the oxygen. That is called a chemical change. So there's two types of changes here, and there's certain ways of actually identifying those changes. Now here we have physical and chemical properties. This is very similar to the changes that take place because if a physical property changes, that is a physical change. Or if a chemical property changes, that is a chemical change. So let's look at these examples here. The melting point. What amount of energy is needed to give a solid object to melt down into a liquid is called the melting point. As we discussed in the previous slide, that any of these state changes is all physical. So that would be a physical change. Now, being flammable is something far different because once something is set on fire, it actually takes those chemical bonds and separates them and makes new molecules. So that's going to be a chemical change. Density. Density, as we know, is only about how close the particles are together. So that is a physical property. We're not separating particles or anything of the like, it's just how close they are together. So that is a physical property. Now, magnetic. That one is a little bit harder to know, but just know that it is a physical property. Tarnishes in air. What is happening when something is tarnishing? If we've ever seen copper turn green or iron turn red, that is a type of tarnishing. What the air is doing is combining with those metals and making something completely new. It's making a new substance, a new molecule on the surface of those copper or iron pieces. So that is a chemical process. So here we're going to talk about physical versus chemical change. So it's the actual change that's taking place. Let's look at some examples. Rusting iron. I swear that I did not look at this next slide before I recorded the last one, but here we have rusting iron, which we already talked about, and that's going to be a chemical change. Now, dissolving in water is a little bit different. When we put something in water to dissolve, all that's happening is that the liquid is kind of getting in between the molecules and it's just dissipating inside of the liquid. So this is going to be a physical change. None of the things inside of the water actually changed its chemical properties. Burning a match. Now this is going to be a chemical change. Anytime that you see fire, it's more than likely a chemical change. Chemical changes happen when the bonds are ripped apart, and there is so much energy that is going into this that the bonds are being ripped apart, and that is going to be a chemical change. Melting ice is a physical change. Again, that has to do with the states of matter changing from one to another, which we talked about always being physical. Grinding salt, that is going to be a physical change as well. Why? All you're doing is just changing the shape of the thing. You're not actually changing its properties at all. If you lick a block of salt, it's going to taste just the same as if you grind it up and sprinkle it into your mouth. We have two different things. We have melting point and we have boiling point. Boiling point is when something is going from a liquid to a gas. We've seen this happen many, many times. Anytime we have boiled an egg or boiled pasta, we have to bring that water to a boil. We're getting it just to the right temperature to where it actually starts to dissipate into a gas. That is called a boiling point. Now, a melting point, as we can guess, is when we have a solid and we get that to the right temperature to where it melts down into a liquid and the particles are able to actually move past each other.